Chapter 11 is about energy in thermal processes, and I'm going to start this with a kind of a little review. And the first equation here is delta V over V equals the thermal coefficient of volume expansion times delta T. And the other equation is essentially the ideal gas law, but it also has, 2 over 3 times U, the internal energy. We're going to be talking about the internal energy of a gas in terms of a new equation that basically goes N times specific heat, MC, mass times the specific heat times the change in temperature. And if we're talking about one particular material with a certain molar mass, that mass can be written as the number of moles times the molar mass times C delta T. And so this can be described as a slope. Delta U over delta T is equal to N times the molar mass times the specific heat, the mass specific heat. Okay, for a moment I'm going to talk about an idealized material, and I don't think you're going to find them talking about an ideal material in the text, but basically what this would have we would draw a U versus T graph, and we would have three phases of the material. We'd have solid, liquid, and gas. And in the solid phase, you would have delta U equals N, or you would have the slope of delta U delta T graph be MC solid. Okay, so delta U over delta T equals MC solid. And I'll just draw that out to there. And you might also, if you wanted to write it in terms of the molar mass, you can write it as the number of moles times the molar mass times the same C solid. Anyway, then you get to the liquid part, but before you get to the liquid part, you've got something called the latent heat of fusion. And this is going to leave the material as at a constant temperature. It's be like a mix of ice water, for instance. You've got part of it is solid and part of it is liquid, but it stays at the same temperature while some of the liquid is converting to solid. And then finally, all of it is liquid, and then then you've got a slope again. Right here, that delta U over delta T is an infinite slope. It's straight up, and then it goes again. Delta U delta T is mass times specific heat of the liquid, and that's going to in general be a different slope than the delta U over delta T of the solid. And then once again, at a certain point, you're going to have the latent heat of vaporization, and then after it gets up to vaporization, you will have delta U over delta T be equal to the MC of the gas. Now, one thing I said, okay, if this is an idealized material that starts operating as an ideal gas at some time at the end, then maybe this would curve up so that it comes back here and it intersects with the 0, 0 point here, because that would be essentially the ideal gas would manage to have that line come back and intersect with the 0 energy and 0 temperature point.